ठीक है।
So now we start unit number 2. So we completed sequence. Okay. Now series. Series depend on the series again. Sequence again. Series depend on the sequence. That's why first of all sequence and then series. So first of all definition. Okay. Series. Let Xn be real sequence. Here sequence. Then the series can be constructed from the sequence. Series. Okay. Sn. Sequence Sn defined as sequence Sn as a sequence of partial sums. Partial sums means what? S1 is the first term, x1. S2 sums are. Sequence Sn is a sequence of partial sums are. S2 addition of two terms. Okay, x1. But x1 is what? S1. S1, S2. Therefore, from this what we get? X2 will be what? S2 minus S1. S2 minus S1. S3 similarly sum third. Okay, addition of three terms. X1 plus X2 plus X3. S3 sums. The sequence of partial sums. So sum of the terms. Few terms. S3. But X1 plus X2 is S2. S2 plus S3. Therefore, S3 what we get? S3 will be what? S3 minus S2. S3 minus S2. S2. S2 minus S1. S3 minus S2. In this way. What will be your general? Sn will be what? Sum of n terms. Okay. X1 plus X2 plus X3 plus Xn minus 1, n minus 1 term, and last term will be Sn term. Okay. So up to this now, sum of n minus 1 term means n minus 1. Therefore, what you get here? This Xn will be what? Sn minus Sn minus 1. Okay. Sn will be what? Sn minus Sn minus 1. X3 will be what? S3 minus S2. 1 less. Sn will be what? Xn will be Xn minus Xn minus 1. Okay. So in general. Okay. In this way. Okay. So therefore, okay. Then okay. So summation Xn n running from 1 to infinity will be a series. Summation Xn will be a series. Series as a sequence of okay Sn of partial sums. So series means sequence. Okay. So any series, summation Xn means series of series. Series is a sequence of partial sum. So is a relation of series and sequence. So in a series, Okay, summation xn is what? Is a sequence of partial sum. Sequence symbol, Sn symbol. Sn, sum of the n terms. Okay, sum of the n terms. So series is a sequence of partial sum. Now about the convergent and divergent. Okay, convergent. About this. Okay, so if this convergent, this okay. So if this sequence Sn, sequence of partial sum is convergent, then series will be convergent. Summation xn is convergent. So series convergent means this sequence of partial sum will be convergent. So this sequence of partial sum is convergent, then series will be convergent. Divergent, same similarly. So okay, if xn, this sequence is divergent, then series divergent. So series depend on now sequence. Okay, so this series convergent when this sequence of partial sum will be convergent. This is divergent if this sequence will be divergent. Okay, so this series now depend on the sequence now. Sequence of a partial sums. See examples. About the convergent or divergent. This small example. Consider series summation n running from 1 to infinity minus 1 raised to power n. Minus 1 raised to power n. So see convergent or divergent. This series. Okay, 2 more questions. Okay, now this given. Okay, series summation xn series as this series. That means what? Xn will be minus 1 raised to power n. Corresponding to xn. Always xn symbol. Sn sum का symbol है. Yes, zero confusion between xn and sn. Xn series. Sn sequence of partial sum symbol. Therefore, I want Sen. I want Sn sum of n terms. Okay, x1 plus x2 plus x3 plus xn and the Sn sum of the n terms by definition. Now here n terms are okay. So n equal to 1 minus 1, n equal to 2 plus 1, n equal to 3 minus 1, n equal to n minus 1 raised to power n. Okay, now what is this now? Plus minus 1. Okay, now suppose this n is a even number. N is a even number. Even. So when even number, then all cancel. Minus 1 plus 1 minus 1 plus 1 cancels are even number. All cancels is. And when is an odd number? N is an odd number. Then 1 minus will be remaining. Okay. 1 okay. Minus will be remaining. So this Sn as a now. This like. Okay. 2 values. When e1 then this one. Now limit n tends to infinity of this is. So limit of this will be what? 0 or minus 1. 2 values, 2 limits are. Okay, essentially this like. So limit of this will be constant terms are same limit. Okay, so 0 or minus 1, but limit does not exist. So there are 2 values of limits. When limit exists, it is unique, only 1 values. So there will be two values, means limit does not exist. Limit does not exist. Limit not exist means what? Divergent. So this sequence Sn is divergent. Limit exists, convergent. Okay, we studied in the sequence chapter. Limit exists, convergent. So this divergence means series will be divergent. Summation Xn, that series is okay divergent. So series depend on the sequence. So the sequence of partial sum is Sn is convergent, then convergent, is divergent, then divergent. Another example. Summation Xn as a n square. Okay, so therefore Xn will be n square. So what will be now your Sn sum of n terms, x1 plus x2 plus x3 plus up to xn, n term addition will be your Sn. Xn sequence symbol, so is it terms. So S1 1 square, 2 square, 3 square and n square. So what is 1 square, 2 square, 3 square, 4 square, n square? By okay, mathematics formula n into n plus 1, 2n plus 1 divided by 6. N into n plus 1, 2n plus 1 by 6. That is a sum formula we know, high school level. Okay, now check limit. Limit of this. So n tends to infinity. N tends to infinity. Infinity upon 6 is infinity. Infinity means does not exist. Does not exist. So therefore, limit of this not exist means okay, not convergent. So Sn will be a divergent. So this sequence of partial sum divergent, therefore series will be divergent. Summation Xn will be divergent. So these examples. Now, theorem. So first theorem on this series about the convergent and divergent, how to check this, like by definition. Now by this theorem, the necessary condition for convergence of the series summation Xn is, so what is the condition? Will be what? Limit of Sn must be 0. Limit of Xn, not Sn. Limit of Xn Xn must be 0. That is the condition after this. Now problem is like, by definition, limit exists, convergent. Limit does not exist, divergent. Now we can apply this now theorem for the further problems. Okay, so series will be convergent when limit of Xn term will be 0, limit of nth term will be 0. only 0, not 1, limit 1, not convergent, will be a divergent. So proof. Okay, so suppose this convergent, suppose the series summation xn is convergent, converges to, suppose say yes, converges to s. Converges means what? Limit exists. Okay, limit exists. Converges means, so limit of xn is equals to s. Summation xn equals to s. Now series means what? Sequence. Therefore sequence, okay, Sn of partial sum is convergent. Series convergence means sequence convergent. Okay, series means sequence convergent. So sequence xn of partial sum will be convergent. Convergent means what? Limit exists. Limit of this Sn must be equal to s. Convergence means limit exists. Convergent. So limit of this xn must be equal to s. So limit of xn will equal to x. That means limit of xn minus 1 is also s. Same, because n tends to infinity position. So limit of xn will be s. The limit of xn minus 1 also s. Xn plus 1 also s. Okay. Yes. Now we have by theory. What in the theory we explained? Xn, nth term will be Sn minus Sn minus 1. See in the definition. Okay. Xn will be equals to Sn minus 1. Limit taken. Limit also here. Limit n plus infinity. Limit of Sn. Limit of Sn minus 1. Okay. So limit of Sn, yes. N minus 1 also s means 0. Okay. So limit of xn will be 0, and that is the condition. Okay, that is the condition. So series convergent when limit of xn term will be 0. Limit of xn term must be 0, then convergence. Otherwise divergent. Okay, so limit of xn term is not 0. We will not get the 0. Any value 1, 2, 3, 4 minus also. Then that will be divergent in that case. Examples. Okay, test the convergence. Test the convergent of the series summation xn for terms are xn is n plus 1 divided by n plus 2, b xn is cos of pi upon n, c xn will be 1 plus 1 by n raised to power n. So 3 examples, 2 very small, 2 marks. So So given series summation xn and where first part xn is n plus 1 divided by n plus 2. Now check rightly limits. Okay, rightly check limit of this xn term 0 or not. 0 then convergent, otherwise divergent. Limit. So how to find the limits are, okay, n plus 1 algebraic function. Algebraic functions are, then what happens? Take the common, highest power common, n common from numerator, n common from also denominator. Algebraic terms, study in the QS100 how to check the limits are. Okay, algebraic terms, highest power taking common from numerator and denominator. And now put the limits. N tends to infinity. 1 first same. 1 by infinity 0. 1. 2 by infinity also 0 means 1. So limit of xn will be 1, not 0. We need 0 limit. Limit of xn must be 0 is 1, but we doesn't get 0, not equals to 0. Therefore, by theorem, okay, given series is divergent, or convergence must be limit 0. Okay, so this first part, A parts. Okay, similarly B. Now B part. Okay, so same some given series and where xn will be. So now xn n term will be what? Cos of pi upon n. Okay. Again check limits. Limit n tends to infinity. Limit of this. Okay. N tends to infinity. Pi upon infinity, 1 upon infinity, 0. 1 upon infinity is 0. Cos 0, 1. Cos 0, 1. So limit of this xn will be 1. Again, not becomes a 0. Therefore, by the theorem, okay. So this given series summation xn is what? Divergent. So for convergent, limit must be 0. Otherwise not. Okay. Next, third part. Now your xn is